So, hello everyone, how are you all? I hope you all are fine and safe. Well, again, welcome back to Quantum Mathematics. I'm one just welcoming you all to a new amazing video in which we are gonna talk about a very crazy looking thing. Like this is literally mind blowing and elegant. You know what it is? This is sine of z equals z times the infinite product as k goes from 1 to infinity of 1 minus z squared over k squared pi squared. So this beastie looking thing actually, and you know what it is? This is Euler's infinite product for sine of z. So basically this was proved by Leonhard Euler himself. And you know what? There are several ways by which we can prove this down. And in this video we are just gonna talk about the one of most elegant thing, which is going to prove this down from this relation. Gamma of z equals limit n tends to infinity of n to the z over z and times the product as k goes from 1 to n of k over k plus z. And believe me, if you are a daily viewer of my channel, so you might have an idea about what it is. This is the Gaussian representation of the gamma function. Gaussian representation of gamma function, right? And we have proved this down in one of my early videos, and we have talked about this one also, that is 1 over gamma of z equals it was z times e to the Euler masculine times z times the product as k n goes from 1 to infinity of, it was 1 plus z over n times e to the, I think it was negative z over n. Yeah, this was the Weierstrass. I think I just made up the second spelling here. It's Weierstrass infinite product for gamma function. So we have talked about these two things in one of, or maybe, yeah, it's not one of my videos. Actually, we have discussed both of them separately in two separate videos, right? So basically we can prove this down using this relation, and yeah, it's pretty fine. Okay, now let me just change the, actually my chalk has been slightly smaller, so I just have to change that. Okay, I just got a big chalk here, so fine. So basically we will be proving this one from this relation also, but in the next video. And for now, let's just consider this Gaussian representation of the gamma function, right? And yeah, believe me, this is also crazy, and yeah, that's really impressive. We can prove this relation down from there itself. Okay, so now let's consider this one. I think I should erase this one also in order to get some space, and it's pretty fine. Okay, so let me just write down the Gaussian representation of the gamma function once again here. So it was gamma of z equals limit n tends to infinity of n to the z over z times the product as k goes from 1 to n of k over k plus z. So this is the representation of the gamma function by Gauss, right? Well, now what we are going to do here, let's just replace z with negative z. Be careful, don't worry about that. I'm just going to tell you why we did that, and you're going to have a better zone after doing this. Just take a look at here. So here it's gamma of negative z, so limit n tends to infinity of n to the negative z over negative z times the product as k goes from 1 to n of k over k minus z. Yeah, it's pretty fine. basically we just have replaced z with negative z all over places where z is just taking on. Next, what we're gonna do is just multiplying both sides with negative z in this equation. So we're gonna have negative z times gamma of negative z equals limit n tends to infinity of n to the negative t z times the product as k goes from 1 to n of k over k minus z. Well, we know about the recursive formula that says gamma of 1 plus z equals z times gamma of z. So if we replace gamma here with negative gamma, if we replace z with negative z, so that's gonna give us gamma of 1 minus z equals negative t z times gamma of negative z. Well, we are having negative z times gamma of negative z here, so we can replace this with gamma of 1 minus z instead, right? So let me just use that board here. So basically this whole thing is gamma of 1 minus z, that is limit n tends to infinity of n to the negative z times the product as k goes from 1 to n of k over k minus z. Yeah, it's fine. Okay, now we are having this equation and this equation, right? So I'm just gonna multiply them both with each other. So basically we are having gamma of z times gamma of 1 minus z, right? Because gamma of z times gamma of 1 minus z is this. And let's talk about their results. So limit n tends to infinity of n to the z over z times the product as k goes from 1 to n of k over k plus z, and then a parenthesis, right? And then if we talk about this one, so from here we can write this as limit n tends to infinity of the product, I missed it, negative z here, and to the negative z actually, and then the product as k goes from 1 to n of k over k minus z, and it's fine. Now since n is tending to infinity and here n is also tending to infinity, so we can just take common, or maybe we can consider only one of them and let all the things be multiplied to each other. So basically gamma of z times gamma of 1 minus z here, it's limit n tends to infinity of n to the z times this one n to the negative z, that's going to be 1 actually, over z, this factor, and then the product, because this both products are going from k equals 1 to m, so we can just consider this single product, and their results or their arguments are going to multiply to each other. So it's k over k plus z times k over k minus z. Yeah, it's pretty fine. Okay, so basically this n to the z and this n to the negative z are gonna cancel out with each other, and since we are not having any kind of n in this whole chunk of big thing rather than this one, so we can just plug this n equals infinity, right? So yeah, we are having an infinite product there, and let me just show you here. Okay, so basically our gamma of z times gamma of 1 minus z comes out to be 1 over z times the product as k goes from 1 to infinity, because n is tending to infinity, so we can just plug their infinity as well. And you know what, this k times k is k squared, and this k plus z times k minus z is k squared minus z squared, right? So basically we are having k squared over k squared minus z squared. So we are having this much amount of things after this solving thoroughly that we just began with. Okay, now we're just going to take the reciprocal here. Take reciprocal both the things. So we are having 1 over gamma of z times 1 minus gamma of z equals, when you take the reciprocal of this, so that's going to be z times the product as k goes from 1 to infinity of, so that's going to be in the numerator and there's going to be in the denominator, so basically it's k squared minus z squared over k squared. And you know what, we have talked about a lot of times for this Euler's reflection formula. We have talked about it a lot of times, and even I have proved this relation a lot of times in my old videos. So it's gamma of z times gamma of 1 minus z is pi over sine pi z. So basically, if I'm just going to take the reciprocal of them, so that's gonna give us, oh, let me just write that down here, or maybe I should write that down here. So if I'm just going to take the reciprocal of this Euler's reflection formula, so that's gonna give us 1 over gamma of z times gamma of 1 minus z equals sine pi of z over pi. So this is what we are having from this relation. And you know what, if you are wondering that how can you write this thing here, so please check my old videos. I have proved this in my old videos. It's not like I'm just using it without any kind of cause. I have proved this down, but I'm not going to prove this down in this video because this is going to take a lot of time to be proven, but it's alright, it's fine, you can just check that out if you want. So basically we can replace this 1 over gamma of z times gamma of 1 minus z with this very sine pi z over pi here. So basically sine pi z over pi equals, we are having z times the product as k goes from 1 to infinity of, well, we can just separate it into two separate rational functions actually. So that's going to give us k squared over k squared x 1 and minus z squared over k squared. Fine. So basically I was going to multiply both sides with pi here. So that's going to give us sine of pi z equals pi z and times the product as k goes from 1 to infinity of 1 minus z squared over k squared. And hence this is the very relation of the one we began with. Well, we considered theta rather than pi z. So basically if you replace pi z with okay, look, let me just make it more clear for you. Don't get confused. So basically if we talk about this relation, so you just have to replace pi z with z. So basically I'm sorry, I don't want to confuse you here actually. So let's plug pi z equals theta, right? So basically z here is theta over pi, right? So let's just replace pi z with respect to theta and z with respect to theta, right? So basically we are having sine of theta equals theta times the product as k goes from 1 to infinity of 1 minus, well, z here is theta over pi. It means theta squared over pi squared. So basically it's theta squared over k squared and pi squared. So this was the thing that we wanted to prove thoroughly, although it's not difficult to just get over there from here, but it's alright, I did that for you. So yeah, just stay tuned for the next video guys, because we are just going to prove this down using the Weierstrass infinite product, right? And yeah, that's really amazing. So basically I'm just gonna bring some videos on this one, and this is really amazing guys. Well, oh my god, Euler, what have you done for us? You didn't left anything for us to do by ourselves. Okay, it's alright guys, and thank you so much for watching this video guys. If you got to learn something from this video, please make sure to like, subscribe and share. And if you have any kind of doubt throughout this video, so please you just have to comment your doubt down below in the comment section. I will make sure to reply over there. So yeah, thank you so much for watching this video guys. Goodbye, take care, love you all guys. Just take care and be cautious, because I'm gonna bring the Weierstrass infinite product proof by which we are gonna prove that down that is written over there. Let me just show you. So it's something like this. So we are gonna prove this down using this thing. I'm sorry, 1 over gamma of z was, I have written this down in the very first beginning of the video, but it's all right. Let me just write that down again here. K goes from 1 to infinity of 1 plus z over k times e to the negative z over k. And again, we have talked about this one in my old videos, so we are gonna prove this thing from this one in the next video. That is why I'm just calling you to just come up in the next video. Thank you so much, guys. Goodbye, take care, love you.